Alright, so here is the second question from chapter 13 on sampling distribution. And we have a question up here, 13.34. Again, this is from a textbook, Baldi and Murray, mentioned over here. So take a moment, pause the video and read through the question. So once you are done reading with this question, we can look at it. So all the type of question you have to see which type of question they have. There are variety. One way we saw in previous, when x is given and area is to be found. This particular is the question where you have to do the reverse analysis, like the area is known and find x. So if you read through the question stem, there is information given to you: normal distribution mu, sigma, and 4 separate measurements were taken, so that's sample n. And what is the blood glucose level L, such that the probability is only 0.25, that the average for measurement is larger than L. So here the 0.05 is the area or the probability that is given to us, and we are supposed to find the L, or in other words, it's asking us to find this x. So we are going to go, this is a reverse fashion, and we are going to use the table inside out as opposed to one that we covered earlier. So let's draw the curve to see what they are asking here. They want us to identify the L, or that particular level. So if I want to draw, I would draw first step, normal distribution, because we know it's a normal distribution with some mu. It's given as 125. I can write sigma over here, which is 10, and then 0.05 and larger than L. So L is located in such a way, so let's say this is L, or you can also call it as X, that this particular area is 0.05. Okay, so right away, you know, based on the total area, this remaining area is 1 minus 0.05, that's nothing but 0.95. Okay, because the table, z table that we are going to use, always gives us area on the left side of that particular value. Okay, so area is given, we have to find x. We have completed first step. Second step is also the same, given data, so I've written down mu over here, sigma over here, the area, and L. So we have all the information written over here, and we know that it should be larger than that particular value, so that's also there. So the next step is find the z-score. Okay, so now here, based on the area, we have to find the z-score inside outside using the table. So if you use the z as 0.05, then you're going to get the question answer wrong, because that is the area on the right side of the curve. Remember, the table always gives us area on the left side of that score. So that's why z, or the area of interest, equals 1 minus, that's the total probability, 1 minus area right side of the L, that is 0.05, that's nothing but 0.95. So that is our area of interest. So now go to the table, and we should be looking for 0.95 and the corresponding z-score. So you can see there are negative z-scores over here, sorry about that. And then what you should be looking at is inside square, because these are the ones that represents area and not the outside. These are the z-scores over here, okay? I mean over here and here. So you should look into that square and look for number close to 0.95, and you can scroll through, you can see that it's still 0.4, 0.38. So scroll down further and you can see there are some 0.9 close related values, and then if you go and find this one is closer, 0.9495, so that's closer to 0.95, and this one is, so your desired or our desired value lies exactly in between here, right? So that is our z of interest. So we have to look for that particular or area of interest, and that for that particular area of interest, look for the course value of z, that is 1.6, but that is not the final answer, okay? Because it's not in the 0th column, it's in some of the column over here, which is the center of these two adjacent highlighted columns. Once you have located that area, just and have the corresponding course z value, you have to add that corresponding columns as a fine adjustment, and you can see the value exactly lies in between these two, 0.045, 0.04 and 0.05. So you can just take the sum or middle number of that, so add those two numbers divided by 2, and that should give you 0.045. So that's just a fine adjustment that you're going to add to this course value. So that's going to be 0.045. So now your z becomes 1.645. Okay, so that is the exact z value that locates the area of our interest. So using the table, we know that the z is 1.645. Now once you know the z, you just have to get the x value, or in this case we are representing it as L. Okay, so get that particular value and then your answer should be all ready. So x, or in this case L, is nothing but z, which we found as 1.645 times your sigma. In this case we saw that it's 10, but actually the sigma is not 10 because it's a sample distribution. Okay, so this, you have to consider the sample size, and they are saying that 4 measurements were there, so n becomes 4. That's why your sigma becomes, or the standard deviation becomes, for population becomes sigma over square root of n, which is 10 over square root of 4, and which is nothing but 10 over 2, which is nothing but 5. Okay, so that's how we got the standard deviation, and for the convenience of space I'm going to write it here. Standard deviation is 5. So now here you should be using sigma over square root of n, because it's a sampling distribution. So it's going to be 5 and then additional mu, and the mu is 125. Now you solve this math and you should be able to get the final answer. So that's 133.225. So now for better representation of how do you get z, I would like to add something. So how do you know, or how do you explain that in steps or assignments, that this was the z that you were looking for? So you can say that you were looking for probability being z more than 1.645, and that was given to you as 0.05, because that's nothing but the area represented in the red, highlighted in the red, that's greater than L value, right? So that's why we are writing it in uh, z greater than 1.645. And but z table gives you area left to that that particular L value or X value. Note that when we say area of interest over here, the area of interest is for z, for z from table. Okay, but if you look at the question, the original area of interest is the red one, which is this area of interest. Okay, but we are considering this area of interest just to get the or derive the z from the table, because the table only gives us that green area left to that L value. And also that clarification I think was pretty clear, that it's a sample distribution, so we always use sigma over square root of n for our population standard deviation. Okay, I think other than that, I think it should be all good.